my name is Steffen Kelch. I work at SAP, and today I'm going to introduce you to OpenMCP. And stop, MCP does not stand for Model Context Protocol. It is Managed Control Plane. So that this is out of the way, let's begin. So let's assume we are Dave, who is a member of a central DevSecOps team and is in charge of orchestrating cloud resources for a couple of very important cloud products. There's a new flagship product, which is an AI-powered mobile app with the name Virtual Sliced Bread version 2.0. And our CEO requests us on a Friday morning to deploy the new flagship product for a demonstration on Tuesday at the Apple Worldwide Developer Conference. I know this is a pretty standard use case for everybody here, but let's just roll with it. As this app really uses personal and organization data, we must really be in control where our data is being stored, and we would like to only store it at a compliant vendor only. So let's have a look at the cloud architecture itself. Of course, for the application, we need a workload cluster where our almighty AI processor is running on, and our containerized applications and API is living. Then, of course, for the data persistency, we want a PostgreSQL database, of course, at a compliant vendor only. So these are now our depending services. Now, how would a setup, a provisioning look like without the open managed control plane? We would first, of course, create the cluster, the workload cluster itself via kubectl, cluster API, or whatnot. Then, after it's provisioned, we would then manually deploy our Helm charts, customized KCL, queue, whatnot on the cluster itself. Then, of course, we would need the persistency layer, and we would provision a database via the GCP API or CLI, or maybe even via ClickOps going into the web console of GCP and doing that there. Then, after this is being done, we need the SQL CLI in order to initialize the structure and maybe the content of the database itself. Then, of course, all of these components need to talk to each other. So we need credentials, service accounts, and so on, so that each component can talk to each other in an automated, seamlessly fashion way. So as you can already see here, there are many, many tools involved, and this rather easy to understand use case is getting complex very quickly. Of course, manual work or semi-manual work is error-prone, and it is also time-intensive. And I did not even speak about day two operations yet. So let's have a look at how would that look like with the open managed control plane itself. So we have here a managed control plane, which is just a Kubernetes cluster, and on that is running cross-plane. The cross-plane Kubernetes, Helm provider, a vendor provider, which is right now the GCP one, and the SQL provider itself. Via the Kubernetes cross-plane provider, we can just order from our Gardener a new workload cluster itself via just a simple manifest. And if you have not heard about Gardener, please check it out and subscribe to it. It's really great. I love Gardener. It does make us working with Kubernetes cluster so much easy. So please check it out. And additionally, with the Helm cross-plane provider, we can then install all of our Helm charts, the containerized application, APIs, the almighty AI processor on this workload cluster. Then, of course, with the vendor provider, for example, the GCP provider, cross-plane provider, we are now able to provision or to request an Postgre database. And with the SQL provider, we can then initialize the schema and also maybe the initial content. So you already see that for Dave, we now have really simplified and unified the whole development experience. There are not a lot of CLI tooling and waiting for him in that case. We have the entire stack, our desired state of our cloud infrastructure. We have it in code inside the KRM. And of course, because cross-plane and the providers are cross Kubernetes operators and controllers, it is self-healing. With that, our software and cloud landscape is now reviewable and also reversible. But how do actual teams now get an MCP build? Because it's very nice talking about what we can do, but how do we actually get one itself? And now there comes the onboarding API into play. The onboarding API itself is also just a Kubernetes cluster. And with that, a developer or any other tooling which understands the Kubernetes API can connect to the onboarding API and request via the kind managed control plane an own new managed control plane. We can set the desired region in which the MCP should be spawned, and we can request what components shall be installed on that and then later on maintained. Additionally, we can also do authentication, authorization stuff here, but we just want to do the default identity provider for now. Simplify speaking, after the onboarding API is doing a little bit of magic, it has provisioned a new managed control plane and installed all of our requested components into that managed control plane itself. And it will also manage those in the long run. After all of that is done in green, as we all know, everything is very easily fast and done in green. A kubeconfig will be published and can be used by the developer and or by the DevSecOps teams in order to connect to this newly created and managed control plane. Now, let's have a look at the technical components that I just brought up and why we are using it. So for the resource orchestration, we are using crossplane because we want to stay confident as our desired cloud landscape is defined in code and its state is continuously observed. As I already said, because crossplane and crossplane providers are Kubernetes operators controllers, they're implementing the reconciler loop, they're detecting drifts and try to apply our desired state to make it into the actual state at the service provider they're talking to, which is very great. Then, of course, we would like to move out our Kubernetes manifest out of the Kubernetes cluster into a code repository. And in order to do that, we really would like to stay in full control of our cloud landscape state files. And therefore, we are using Git repositories and also, for example, GitHub. So we are using Flux as our GitOps integration, so that Flux is doing the heavy lifting of comparing, syncing, and applying the latest Kubernetes manifest or packages that it looks at. With that, we now have a history of changes of the managed control plane resources, which are also, of course, now revertible. And all the changes are now reviewable and validated through PRs and your pipelines that you build on top of it. Now, SAP is really a big company, and we have a lot of security and product standards. To enforce those security and product standards in our own cloud landscapes from code, we are using as a policy engine Kyverno. And it's very easy for us to define the policies to prevent undesired behavior or configurations at the managed control planes that we are offering for all of our teams who wants to use them. Then again, there are a lot of credentials, a lot of secrets flying around so that each component can talk to each other. Therefore, we also need secret management. For this, we are using the very good, very great external secrets operator. Because with that, we can manage, rotate, and audit all of our secrets. With it, we can pull and push from and to many credential stores. And we can connect our company secret store with these. Additionally, we can also pull, push, and do whatever we want with secrets from and to the managed control plane and from and to the work clusters. But last but not least, how do we now do actual platform engineering, this current buzzword besides AI in our space? Of course, we're using OpenMCP itself. But let's let's take a little step back first. So these components that I just introduced all of yourself, this is only pre-bundled managed control plane setup for us, for us, how we are using it as SAP. If you do not like, for example, the GitOps or the resource orchestrator or the policy engine, you can replace it with anything that you want. You can tell with the OpenMCP, please use, for example, Argo CD with that. And then your managed control planes will be spawning with the versions that you have released and published for the usage within the managed control plane. So OpenMCP is easily extendable to your needs, to your projects, to your company, to your business unit, and is completely open source. And we are using it inside SAP very successfully. So let's get back to platform engineering itself. How can we do that? So simplified speaking, with one managed control plane, you can, with the cross-plane Kubernetes provider, you can connect to the onboarding API because it's also just a Kubernetes cluster. And then create and manage other managed control planes with that over the onboarding API. This is very good because with this concept, we can also define platform-defined content like the secrets, policies, operators, what we want to install additionally on that, so that each of those teams does not need to manage those or analyze how does it work, how do we set it up, how do we manage and orchestrate it. This can all be done from a platform perspective in a central place for your teams, for business units, for your project as you just need. For us internally, this speeded up really time that development teams needed for the infrastructure so they can really focus much more on their core task in actually building and building the business applications that SAP is so famous of. So this also killed ramp-up time because, for example, we out of the box already connected every MCP to our company OCI registry and our company identity provider. So the teams do not need to do that anymore. Also, additionally, automatically the MCP writes to our company audit log service, so they even do not need to take care of that. Additionally, we have, as I said, pre-configured open source tooling like Kyverno, Crossplane, and many more. And internally, we also have a lot of advanced guides and guides for them to showcase them how can they actually work, configure each other to work from end-to-end process, for example, for Kubernetes application lifecycle, for example. So let's rewind. With the open managed control plane, we now really have simplified and unified everything. We have everything in the KRM, our whole stack of the cloud landscape and software. It is self-healing and it's now reviewable and revertible. So that's really great. So David, on a Friday after lunch, he's really happy that he used the OpenMCP offering inside of his company to really spin up all of the infrastructure that he needed and that he could just easily do that. And during lunch, everything reconciled, and now everything is great. So with that, he now really can celebrate because he is now able to join his colleagues at the happy hour at the bar and drink margaritas with them and enjoy the weekend. And because everything is self-healing, even if the CEO at the weekend is trying to do something funky stuff on the Kubernetes cluster, it is self-healing, and David does not have to work, hopefully, on the weekends this time. Now, let's look into the mission and scope of the project in the context of NeoNephos. OpenMCP is a Kubernetes-based platform that extends the power and simplicity of the declarative Kubernetes API to the management of infrastructure and application lifecycles. It enables infrastructure as data, empowering platform operators with robust automation and allowing service consumers to use a unified API experience for all their cloud-native resources. The mission of OpenMCP is to eliminate the need for various tools with different workflows, configuration paradigms, and deployment methods. And now this is where I might shit my little pants. Let's go to the demo. So what I will show you is the managed control plane UI, which acts primarily on the onboarding API itself. So, and this, of course, is also open source. So let's sign in. And here you can see the project. We are able now to create a project. First, there's a project, then there are workspaces, and inside those workspaces, we have then the MCP itself. Of course, I have prepared a little bit something, and as you can also see, everything here is YAML. So this can be what I'm currently showing you. This can be done via ClickOps, or it also can be done just via automation, via kubectl, or your tooling of your choice that is able to connect to the and understand the Kubernetes API and is able to connect to the to the onboarding cluster itself. Now, let's go in here. We have our workspace, and also this workspace, as you can see here, is also in YAML. This was not the right one. This is a kind of workspace that we have in here with also the members and so on. And here we are now able to create a managed control plane itself. Now let's give it a name, like our famous test 1, 2, 3. The charging type and target is for us internally so that we know what which unit, which team, which product has cost us the some amount for X for this amount of managed control planes. So we can just also add users or service accounts here. So you're also able to create your own service accounts on the onboarding API to do additional automation. And the next one is you now can select which component you would like to manage. And as I said earlier, those components are only the components for us SAP inside. So this is a SAP flavor. Your own OpenMCP onboarding API, your release channel, what you are offering might look different. But with OpenMCP, you can easily extend that and change that to your liking. So please do not think that this is the only components that are available or manageable. No, you can do that with your own components in which version you ever like. So we would like to have cross-plane. We have a couple of providers here. Some are inner source, some are open source. So if you do not find them open source, please do not feel bad. Then, of course, we have the external secrets operator. We have a couple of versions that we are allowing the users to switch to. And of course, if when there is a new version, we can then just tell our MCP in the spec to use the new version, and it will update and install that automated seamlessly. And with that, we now have our MCP, our manifest, with the versions that we want, and we could easily just create it. And now, in a second, it should appear. So now, behind the curtain, the magic is being ongoing, and we can already connect to MCP that I already have created. You have also this very great insight in your MCP to see which components have been installed, with what versions, what is the YAML for that component, what is the current manifest, what is the current status. You also see that here in a very nice way. And if we would have had already some provider configs or managed resources on that, you would also see that here. And the same for Flux and also for the landscaper. Landscapers also something very powerful from SAP open source. So Landscaper, please check it out. Gives you great deployment tooling. Yeah, good. And with that said, let's jump back to the presentation. So now your mission is now really to go out there and to find one crossplane provider or any other automation tooling of your choice and automate a couple of your manual tasks inside your company, inside your team, inside your project. And of course, come back to us and tell us, what is your story? How did it feel? Where were the gaps? How could we influence each other? How could we help each other? Maybe. Everything that you just have seen here is available at the GitHub organization OpenMCP project and also at the GitHub pages. So please feel free to visit and subscribe. And with that said, I am finished, and thanks a lot, everybody. Please stay in touch, and if somebody has any comments, feel free.